Alright, today we have a Nissan Navara 2008 model. Problem with this car is ABS warning light is on the dash, and we're just gonna diagnose this car today. Just gonna check the fault codes, read faults. I'm on the ABS computer here. So it's coming up with the rear left-hand sensor, wheel speed sensor. Let's go and check our live data and just verify if the sensor is actually reading or not. Just gonna pull up all the wheel speed sensors here. And here we got left, right, front, and all that. Just interested on the rear speed, and I'm gonna just spin this left-hand rear wheel and see if the speed changes. On the screen you see a right-hand speed sensor is giving us some reading, but left-hand is staying 0. The reason the other side is giving us reading is because the other side is also spinning, because this one is a lock diff type differential. So basically the sensor is not reading. Before we do any testing, I just want to quickly explain the basics of ABS wheel speed sensors. They're basically two types: passive and active. Now, the passive sensor is not very popular anymore. Back in the days, they all used to use passive type sensor. A lot of the new cars have active type wheel speed sensors. The difference between them is this one makes an AC sine wave, and this one, active type, makes your digital signal if you're looking with a scope. Now, another difference between them is passive sensors do not need external voltage source to operate. Active do need external voltage power source to operate. So that's why it's a passive and an active. Active will only work when the power is supplied. So basically when the key is on or the computer is active, then it's gonna start producing signal. Active can produce signal without external source. All it needs is you gotta spin the wheel and it start making AC voltage. So if you're looking on the scope, you probably will see something like this sine wave on a passive sensor. On an active sensor, you will see a signal like that, a digital signal. And as the speed increases, the AC sine waves gonna increase in amplitude like that. So this amplitude increases. On an active sensor, the amplitude stays the same, but the frequency will be faster. So instead of looking like that on a low speed, if you are turning the wheel on high speed, it's going to look very much like this. So basically the frequency is going to be a faster on active signal compared to the amplitude gonna go higher on passive type signal. So today on this Navara, we're looking at active type sensor. So if we decide to do a scope testing, we'll be looking at something like this type of signal. Now, how they work is the computer sends signal. So I'll just draw a little picture here. I'll just get this out of the way. So we're talking about this active type speed sensor. So computer sense, this is your ABS module, let's say, and one of the speed sensor, in our case we have a left rear speed sensor fault. So let's say this is our sensor, and then we got our wheel, reluctor wheel, tone ring, magnet, whatever you want to call it. So this is our sensor, and this is a tone ring. Now computer sense earth on one wire, and computer will send, depending on the type, depending on the car, anywhere from 5 volt up to 12, 13 volt on one of the wire. Now this earth is pretty solid earth. You can put your test light and to the battery positive and it will light up. The earth is pretty solid, but the 12 volt supply, the power supply, if you check it with a multimeter or LED test light, you'll see 12 volt. Let's assume it's a 12 volt system. Like I said, it could be 5 volt sensor as well. You'll see 12 volts on your meter, but if you will go to put a test light in a normal type bulb type test light, the test light might not light up, or it will be really dull if you check right here, because it's not really a very strong power supply. It's just a very weak power source for the sensor. Now when we're checking the signal, we're basically checking the signal right here, and you can put your earth terminal on your sensor earth, or you can go to body ground. It doesn't really matter. So when you're checking your signal here, you're gonna need to see something like this. So what's happening here is it's a square wave. My drawing is not very good, but it's a square wave. So what you're gonna see is a constant 12 volt, let's say 12 volt supply, and this reluctor wheel, the tone ring magnet, gonna drop that voltage down just a little bit. We're not gonna see 0.12, 0.5, something like that big square wave here. We're gonna see really small changes, really small voltage drop on the signal. We're talking about maybe 100 to maybe even 300 millivolts, somewhere there. A really small voltage change you're gonna see if you spin the wheel, and as you speed up, this frequency gonna be faster, so the waveform gonna come closer, like I'm showing up here in low speed, and this will be something like a high speed. That way you know the sensor is producing some signal. Now when you're checking this type of sensor, first thing you're gonna do is you can do this unplugged or plugged in. You want to check for earth on one wire, and you're gonna check 12 volt power supply on another wire. If there is a voltage supply, everything is there, that means more than likely the wiring and the ABS unit is good. Now if you don't see that, obviously our problem is up this way, so we're gonna have to tackle the wiring or the ABS unit or the power supply. But if you see earth and the power there, the problem more than likely in the sensor itself. Now sometimes the tone ring can be damaged, like let's say on a lot of wheel bearing these days, they have the magnet attached to the wheel bearing itself, so they can sometimes break. There's a lot of possibility how they can break, a lot of different scenarios, but few things I can think of is they can break in half. You know, the tone ring can have a broken teeth, or you know, somebody who did the bearing didn't put the bearing in the right direction, because there's a magnet only on one direction, on one side of the bearing. So we have to make sure that the magnet will face the sensor. And I have seen mechanics who put it wrong way and the ABS speed sensor doesn't work. Now also with the tone rings like this, sometimes when you're changing bearings and all that, mechanics can bend that wheel as well. I have seen scenarios like that too. But when you have a broken tone ring or ABS, the magnet on the wheel bearing, you can see that on a scan tool, and you can also see that on the scope too. Also, again, if it's completely missing, then it's hard to say if it's a sensor fault or the rings, reluctor wheels fault or the magnet's fault. But if it's only partially broken, so what you're going to see on the scan tool is as you're driving, you got to watch the speed. So it's going to jump up and down, like you'll see 20 kilometers an hour, and next second, even if you're doing 20 k's an hour, next minute it will jump up to like 50, come back to 20. You know, the numbers, the speed of that sensor is going to, go up and down just randomly. That's one way you can check if the tone ring has a problem. Another way you can check on the scope, if it's a digital type, like I said, active sensor, on a scope, as you're spinning the wheel, what you're going to see is you're going to see like a voltage drop, and then you're going to have a sort of like a large gap, or another one here like that, square wave, then large gap. So you're going to see inconsistent on the signal wire like this. That way you can tell there's something wrong with the magnet or the pickup wheel, the magnet ring or the tone ring. If you see something like that, or on a scan tool, if you see the numbers going up and down randomly on that one particular wheel, we know the sensor is reading, because sensor's job is to modify the voltage as it go past the magnet or the ring. And it is doing it, but it's not doing it the way it should be. The reason it's not doing it because there's something wrong with the magnet wheel. So if you see something like that, or on the scan tool, like I described, numbers going up and down, the speed numbers, it's more than likely the problem is in the tone ring, and no point checking the sensor or the harness or the ABS unit in that scenario. So this is the wiring diagram for this vehicle, but we don't really necessarily need a wiring diagram. Like I explained to you on the whiteboard, basically there's your ABS unit right there, and we got 4 sensors, speed sensors. Now the one on the pink highlighted is a blue and a pink wire going into that. That's our left hand rear sensor, which is the problem sensor, and we'll be doing all the testing on them wires. Now one of them gonna have a earth, and one of the other one's gonna have a 12-volt feed on it. Back rear diff, we got left hand sensor right here with 2 bolts, and there's your wiring goes up and connects to that plug right there. I already got my scope connected there, but anyway, you can see there's a pink and a blue wire there. Just took it off the mountings for easy access. So there's the same sensor on the other side, similar sensor right there. Same thing, the wiring goes and connects up to that plug right there. Now I've got my another channel for the scope hooked up there, so we can compare the waveform. On the scope you can see we got 12 volt on both the channel. Like I said, I am connected to channel A and B. The channel B, red channel, is my problem sensor, and the channel A, the blue channel, is a working sensor. We know that, so we're going to compare what sort of data signal we get here. Now one of these gonna have 12 volts and one's gonna have earth, but if we check it right here and we see 12 volt, that means we know there is 12 volt and earth present, right? Anyway, so now what I'm gonna simply do is I'm gonna turn the wheels now, and I'll just change this voltage scale, time to 1 second. Now we're gonna spin the wheel, and you can see as I'm spinning the wheel on the scope, and I also put this scan tool data as well on the screen. So as I'm spinning the wheel, you can see our right hand sensor is reading 2-3 kilometers per hour, but the left hand sensor is doing nothing, is staying at 0 on the scan tool. Let me pause that. Now let's focus up here on the scope here. Like I described on the whiteboard earlier, see how you got a little bit of a small square wave here compared to the red channel, which is straight 12 volt, a bit lower than 12 volt because the battery is a bit weak on this car. I had the ignition on for a while now, but it's just 12 volt battery voltage there. But on the blue channel, which is our working right hand side sensor, we see square wave up and down. If I zoom it in there, we can see a bit more detail. Let's just grab that, and as you can see, the red channel is staying at 12. The blue channel, we have some activity happening there, and as we discussed on the board, they're not going to have a huge amount of voltage drop like a typical sensor wave, square wave you see. It's only going to have a very, very small voltage drop. We can measure that. We'll see here what's this one's doing. So probably go right somewhere close to it. And this is just a rough idea on how many voltage. I'm not really doing it very precisely. So we're looking at about 350 millivolts, somewhere there between the voltage drop. Right there, and this whole time I'm spinning the wheel, and as it gets to there, I stop spinning the wheel and goes back to its 12 volt or source voltage, whatever it is, depending on the car. It could have 5 volts, 8 volts, 9 volts, 12 volts. The car computer can use any voltage depending on the different car models. Now we know at this stage that our left hand sensor is producing signal, right hand signal wheel is producing signal, left hand wheel is not producing signal, and we got the fault code, and we can see on the scan tool as well that this speed wasn't increasing for the left hand side, only the right hand side speed was increasing. Now we have verified the power and earth. What we can do next is, if we want to be clever, we can also do like a bypass activation test, and I'll just show you how it's done. I'll just play that now. Now we're gonna only focus on red channel, which is the sensor that's not working. So I'll just turn off the blue channel for now, and I'll put this scope, the scan tool up here, and you can watch it there too. Now for this bypass test, what you're gonna need to do is you're gonna need earth supply. So I like to use a LED test light for this type of test, because this voltage supply is a very, very weak one, so we don't want to fry the computer. So always best to use a LED in this instance. You can use the normal bulb style test light, but I have used it in the past without hurting the computer, but I just don't want to take the risk and give out the false information just in case. So basically all I'm doing is the other side of the test light to the battery negative, or just find a body ground somewhere, which I'm gonna do now. Yeah, just to the battery negative and get the tip of the test light. Just the tip of the test light. We're gonna touch this power wire, which is on this red probe here. So I'm back probing onto the power wire, which is your blue wire coming from the computer. So all I'm gonna do is I'm gonna touch this momentarily, and you can watch on the scope and the scan tool that we're gonna receive some signal there. So just giving earth through the test light onto that power supply wire, and you can see we can see some square wave on the scope, and also you can see the speed numbers increasing on the scan tool as well. This is one test you can do to verify the wiring and the computer. Now at this stage it's looking like we're gonna need a new sensor for this problem, but before that, like we discussed on the board earlier, we can have a problem with the magnet ring or reluctor wheel ring. Sometimes on the bearing, sometimes they'll have a separate reluctor wheel on the axle, and in this case this one has a reluctor wheel in the axle. So what you're gonna do now, I'll just take this sensor out, and we're gonna see hopefully the reluctor ring in there. Alright, just take the two bolts off and this sensor should come out. Now, one more thing you can also do in this sort of scenario, on most cars you can swap the sensor from left to right. Usually they are same sensors, and that way you can verify is it the sensor or is it the magnet that's a problem. So just put a known good sensor from the other side. You can do that, but in this case I can't do it because left and right on this Navara sensors are different. Even if they look the same physically, the angle they go in that hole and the surface where it reads the magnet is a little bit different. That's why you cannot use left and right. It's not gonna work. So for that reason, I'll have to take a different approach on this vehicle. So if you look in that hole in there, you can see that wheel. Hopefully this camera is picking up for you, and I'll turn the wheel slowly. You can see that tone ring in there turning with the wheel. Now physically I don't see any damage in there, it looks intact. And this one's easy because you can see it through the sensor hole, but some cars you can't see that as easily as this one. It could be on the bearing, wheel bearing itself, which is really hard to see. And in that case, if the sensor magnet is, or the wheel is completely missing, you're gonna have no signal as well, like we discussed on the board earlier. If it's a partially damaged, you're gonna see that variation on the scan tool and the scopes on the scope. That variation and speed gonna jump from randomly different numbers while you're driving on that particular problem side of the wheel speed sensor. But sometimes we can have the whole magnet of the bearing is completely damaged. So in that case, what you can do, one more test, to verify that is you can do an activation on the sensor itself, kind of like a bypass test, but I'll show you that after I will change this sensor, because we know this sensor is not working, judging by how the wheel magnet wheel looks inside there. I'm pretty confident we're gonna need a new sensor, so I'm gonna do that, put a new sensor, and then we will talk about the activation test. Alright guys, I got my new sensor installed. I still got my scope probe plugged into the connector up there, and we got a new sensor here. Now just before I was talking about doing an activation test, if you can't see the reluctor wheel itself on the bearing or the axle, what you can do is you can manipulate this signal by just using a metal, any metal. You can use a spanner. I'm just using a ratchet handle, so I'll get you focused on the scope and the scan tool, and you can see I can manipulate that signal and make the same sort of signal just by touching on that sensor, just going past that sensor, just like that. And you can focus on the screen and you can see you're getting the exactly same signal like we should see, like the good working side sensor was producing on the scope earlier. You can do this on this scan tool as well, but it's going to be a little bit hard to sort of generate that signal for the scope. But every now and then on the scope you can see it's going 1-2 kilometer per hour there every time I'm doing it right. But if you have a scope, it's very easy to see. You can manipulate that signal, that way you know if the sensor is working or not, and that way you can verify if your wheel bearing is bad or the reluctor wheel is bad or not. Now I'm simply gonna put this in the sensor axle there and put the bolts on, and we'll see if this will fix our problem. The new sensor didn't come with the O-ring, so I'm just using the O-ring from the old sensor, because right here it needs to be sealed for the differential oil, otherwise it's going to leak out. So don't forget your seal. So just put it right on the sensor. Now we got the sensor on, and we also got the scope still hooked up onto my 2 wires. Now we're gonna go and have a look on this screen, see if we get our signals back. Now I'm just gonna manually turn this wheel, and we got speed on the left and right sensor, and you can see on the scope we got the signal that you wanted to see as well. Now that's a fix, guys. That's how I do ABS diagnostic. Hopefully this video will help you guys out there. Thank you for watching.